Hello again everyone, welcome back to ptet.chemistry channel. My name is Dr. On, and in this tutorial video, we'll go through an older Cambridge International A-Level paper 9701 for this not June but November 2015. This is a paper 4.1, which I believe is either the same as 4.2 or 4.3 for this exam series. I wasn't very sure, but what we know is really that in the older syllabus, there used to be section A and section B. We're not going to pay so much attention to that because I'm doing a question by question tutorial. So realistically speaking, I'll only be going through questions that are relevant to the current new syllabus, which have been revamped ever since 2016 onwards. So be careful when you do all the past year papers, yeah? In this first question, we have calcium. Calcium is a main group metal. It's a group 2. So group 2 metal. We're going to complete electronic configuration for calcium atom. So it's in the 4th row. So it's period 4 chemistry. So this is 1s2, 2s2, 2p6. And then you start off to sodium and magnesium, third period chemistry, so 3s2. And then you go from aluminium all the way to argon. And then you fill in a new row, which is 4s. And you are group 2. You are the second element in the s block on the left side of the periodic table. You are 4s2. And altogether, you have 20 electrons based on this 20 number of protons in the atom. When you have a +2 oxidation number, you have a calcium 2+ ion. So you know calcium atom have lost 2 electrons. And you're going to lose from this 4s orbital. So you're going to end up with 3s2 and 3p6. This is the same as an argon, which is a noble gas electronic configuration. Although this is an ion with still 20 protons, because you have just lost 2 electrons, you have 2 extra protons than electrons. You are positively charged now. This next question, this is part of AS group 2 chemistry, obviously. You want to prepare calcium nitrate. That means you want to make calcium nitrate in an acid-base reaction. So this is going to be your neutralization. So if we think about it, all nitrates are soluble, and you know how to prepare soluble salt from your O-level, GCSE or IGCSE level chemistry. So we're going to react this calcium oxide or calcium hydroxide. So calcium hydroxide, which is calcium hydroxide solutions. And then if I react that with, what do I want, nitric acid, so that I will get nitrate. They'll give me calcium nitrate, the formula of which group 2 ion Ca2+, nitrate ion NO3-. If we look at something what we call the valency, which is the combining power based on these charges, when you do the cross multiply, you're going to get that. That is how many of those ions you have. This is one of that, and you have 2 of that NO3-. You're going to end up with Ca, bracket NO3 twice, and you will get water. This is part of neutralization, right? So we're going to balance every single equation we write. 2 nitrate comes from 2 nitric acid, and we're going to have 2 hydrogens, so we're going to have 4 hydrogens, therefore 2 water molecule there. The next bit of this question, this is about thermal decomposition. You're going to decompose this anhydrous calcium nitrate. Anhydrous means no water of crystallization. So this white solid that you see, identify this white solid. When you decompose nitrate, just in general, a group 2 nitrate has M2+, 2 nitrate ion like that. And then they will decompose to MO, which is M2+ and O2-, group 2 oxide. You're going to get 2 NO2 gas that comes from the nitrate. And then to balance your equations, when you get oxygen gas, you have to get half of it because you already have 1. And 2 times 2 is 4, plus 1 is 5. You have 6 oxygen atoms. So you cannot have oxygen atom that exists as molecule. So I have half of that. This is a brown gas. This is a colorless gas. When you see this brown gas, you're supposed to test for this colorless gas with a glowing splint that will relight. So this white solid is not going to be the gases. Instead, because we started from calcium nitrate, we are going to get calcium oxide. So the white solid is calcium oxide. They didn't ask for name, they didn't ask for formula. If you write down the formula, it has to be the correct one. So Ca2+, O2-. As you can imagine, the valency when you do the crisscross, it has to be the simplest whole number ratio. So there's 1 and 1. So you can imagine 1 of that Ca2+ cancel out the charge -2 of that Ca2+. suggest another observation for this reaction. So besides leaving you a white solid, this is actually a white solid as well, giving you another white solid. What else do you see? Earlier I mentioned about the brown gas. So you know, NO2 is brown, so a brown gas is observed. Or you say brown gas is seen or is observed, that one should be alright. You cannot see a colorless gas. Please do not write you see a colorless gas. The next bit is a common essay. This happened to be lower mark than I expected it to be because they already provided you the trend. So in the older syllabus, they don't use the new syllabus type. So they use the Roman numeral. You can probably think about this as just group 2 like this in your new syllabus. Okay, always have a look in your specification, especially when you do all the past year papers. The ease of thermal decomposition. How easy is it to decompose? It becomes harder to decompose because it becomes less easy to decompose. So what we can say is down group 2, there are more filled electron shells. So there are more filled electron shells. And what does this have to do? So we can say the ionic radius increases. The ionic radius of the M2 plus, because all the group 2 they form they exist as M2 plus cations in their group 2 nitrates. That will increase, they will get bigger, but still the same charge, but still plus 2 charge. So overall charge density would increase because overall charge density would decrease going down group 2 because your charge is the same, charge over size, but your size is getting bigger. Charge is the same divided by size getting bigger, so your charge density of M2 plus decreases, and therefore we can say the M2 plus become less polarizing. So the cations are polarizing on the NO3 minus, so the NO covalent bond become less weakened, so it's not as weakened as much, therefore more difficult to decompose or more difficult to break. That is why the temperature of decomposition will be higher, but they're not asking on temperature required. They're asking you on how easy is it to decompose, because it's become much more difficult to decompose. So how easy it is would decrease down group 2. This next bit is actually A2 energetics. So this is part of advanced energetics, building upon what you have learned from AS. There is something to do with the standard conditions, the theta there, and then hydration and the standard conditions. So one of the mark would be under standard conditions there. So what do we know about hydration? Hydration is basically things like Na plus gas plus a large amount of water, and then you get Na plus aqueous. But it doesn't just, apply to cations. You can also get hydration of anions, such as Cl minus gas plus aqueous. They're going to get Cl minus aqueous. These are just in terms of the equations I know. These are hydration of your Cl minus. This is hydration of your Na plus cation there. So let me just move that aside. So there's your Na plus cation. Hydration will always be exothermic, never endothermic. If you think about what is happening around the Na plus ions, around the cation, you will have the electronegative oxygen, and this will be delta negative oxygen, delta plus like that, and then you're surrounded by delta negative oxygen of the water molecule. So this is what you call ion dipole bond. Ion from the cations or the anions, dipole, they come from the delta plus delta minus of water molecule. You form ion dipole bond, whereas there's no interaction between the gaseous ions because they're so far apart. One of the assumptions for ideal gases, if you want to think of them as ideal gases, that is. Okay. So what is meant by this definition then? So delta H hydration is going to be the enthalpy change for a certain process. So it's the enthalpy change when 1 mole of gaseous ion, it has to be 1 mole because it's in kilojoule per mole. Per mole of what? Per mole of the gaseous ions. I don't say cations, I don't say anions because it applies for both cations and also anions. Dissolve in a large amount of water or dissolve in a huge excess of water. And this is you can say really to give infinitely dilute solution if you want to. And I don't think that's too important there, but then we have to really then specify under standard conditions as part of that requirement in that definitions. So standard condition will be 298 Kelvin, 1 atm pressure. The next bit is basically a calculation question. You are asked to find lattice enthalpy, and we are given hydration enthalpy as well as enthalpy of solution. So solution is got nothing to do with hydration. It's just the enthalpy change when you dissolve 1 mole of the substance in a large amount of water to give infinitely dilute solutions under standard conditions. Again, they look very similar, but here this is 1 mole of the substance. Here hydration is 1 mole of the gaseous ion. So what do we have if we write one equation for the enthalpy of solutions? So this is a solid plus aqueous, and when you dissolve in water, all nitrates are soluble in water. So you know about all nitrates are soluble in water from solubility rules back when you were doing much simpler chemistry. I'm going to relate this to gaseous ions because that's the relationship with hydration enthalpy definition. So going from the solid to the gas, actually that one is the other way around. Forming 1 mole of the ionic solid from its gaseous ions, that thing is going to be lattice enthalpy. And this lattice enthalpy is going to be whatever I want to find. This is enthalpy of solution, and this is minus 19 kilojoule per mole. The gas hydrates into the calcium 2 plus cation. There is 1 of these, but there is 2 of that, whereas this enthalpy of hydration is for hydrating 1 mole of NO3 minus. So I need to do 2 times minus 314 there. If I press that onto the calculator, minus 314 times 2, I get minus 628 kilojoule per mole. And this thing here is hydration of calcium 2 plus, and this is going to be minus 1650. I should really clarify that this thing here was 2 times hydration. 2 times hydration of NO3 minus, and is equal to that, which is equal to minus 628. In AS chemistry, you have learned about the use of Hess law. Hess law says that the enthalpy change of a reaction does not depend on the pathway you take. So you can take a direct path or an indirect path, the enthalpy change will be the same. So what I'm going to do now is I'm going to go this way. So this is the direct path. So what I can say is minus 19 will be equal to going the opposite. So that is minus the lattice, because the lattice was defined as forming 1 mole of the ionic solid from its gaseous ions. So here I'm going opposite that. So there's minus lattice plus the 1650. Again, that is minus 1650, going the same way. So it's adding with that. Always use bracket because you never know if you will make any mistake. Now they want the lattice enthalpy. I'm going to move the lattice enthalpy to the left hand side, and then I move the minus 19 to this side, I get plus 19. This is minus lattice, become positive lattice. This is going to become minus 1650. It's going to become minus 628. Now you're ready to just press your calculator, and you get minus 2259. The first thing you notice is you get a negative answer. You are forming 1 mole of the ionic solid from its gaseous ions. So you're not breaking anything. You're just forming 1 mole of the ionic solid. It is always going to be exothermic based on that definition, sign, value, and unit. Common things to look out for. Last bit of this question, 12-mark question. So this is about comparing the hydration enthalpy of Ba2 plus versus the Ca2 plus. So the hydration enthalpy of Ba2 plus is less exothermic, so you are forming weaker ion dipole bond. So if you think about ion dipole bond, so you are forming the bond between the ions and the dipole. Both of them are dissolved in water, so there's got nothing to do with the dipole. Everything has got to do with the ion. This is to do with the charge density of the ions. So what we can say is, for 2 marks, what we can say first of all is Ba2 plus has a bigger ionic radius, or is much bigger compared to Ca2 plus. But then we must also talk about the size. So bigger ionic radius than Ca2 plus. So that's the size. Both have +2 charge. So then we have to talk about charge density. So charge density is charge over size. So charge density of Ba2 plus is lower than the charge density than that of calcium 2 plus. That refer to the charge density of calcium 2 plus. So therefore, Ba2 plus will form weaker ion dipole bond. Ion dipole bond will be weaker with the water, with water molecules when hydrated. And as such, since you are not breaking anything, as you are just bringing the gaseous ions together, surrounded by water, by a large amount of water, so the weaker your ion dipole bond, as I did mention earlier, the weaker your ion dipole bond between the water molecule, which is polar, and your cations, the less exothermic, because forming bond will release energy. Forming bond is going to be exothermic. So form weaker ion dipole bond with water molecules, so therefore, well, basically that's it really. I don't really have to repeat the question. Since I already started, I might as well say that it's just less exothermic. Okay, and that's the end of that 12-mark question. Very nice and easy start to this first question.